Professor Adam Reese stated that our understanding of the universe was completely wrong. Nobel Prize winner Adam Reese warns of a strange discovery made by the James Webb Space Telescope. The universe is expanding in a way that we no longer understand. Webb shows us galaxies that are so strange they seem impossible. Our science has come to an end, and what for some is a failure across the board is, for researchers like Adam Reese, the beginning of a new science that brings long overdue answers to elemental questions about the universe. Reese knows that the expansion of the universe and Webb's crazy observational data are connected, and perhaps the whole crisis is down to one tiny detail that we have simply overlooked so far. Even the old Hubble Space Telescope had shown us a strange image of a complex galaxy that is unusually old. The galaxy, called GZ9 P3, was for a long time just a blur of light, and we could hardly find out any more details about it until Webb came along. The new telescope superstar not only confirmed the existence of this galaxy but also its unusual age. GZ9 P3 existed only 510 million years after the Big Bang, making it a galaxy in the relatively early stages of the universe, which is thought to have begun 13.8 billion years ago. GZ9 P3 has now been thoroughly investigated by the International Glass Project, and more inconsistencies have come to light. GLASS stands for Grim Lens Amplified Survey from Space. This project searches for the light of the oldest galaxies in the universe. The results showed that GZ9 P3 was not only unusually advanced for its age, but is very likely already the result of a merger between two or more smaller galaxies. This, like the existence of the galaxy itself, is a scientific miracle. 510 million years after the Big Bang, galaxies may theoretically have already existed, but they are unlikely to be as developed and large as GZ9 P3. Among other things, the fact that galaxies have already merged at this early point in the universe turns our old theories of galaxy evolution on their head. The new study by the JWST also shows that GZ9 P3 has a double nucleus, which could indicate that the merging of the galaxies could still be in full swing at the time the image was taken. The GLASS team discovered that GZ9 P3, similar to other early galaxies observed by the JWST, is already so massive and mature that its appearance is unusual for galaxies in the young universe, to say the least. Many researchers these days are also talking about the impossible. Although we must, of course, be careful here because these galaxies clearly exist and are therefore not impossible, it is simply impossible for our science to explain their existence in terms of our cosmological models. What is fascinating is that these galaxies already contain several billion stars in this early epoch, and yet we are in the era of the end of the Dark Ages, which means that only the first stars should actually be visible. James Webb was constructed and launched into space for the purpose of showing us exactly these early stars. But instead of the first protostars and loose clusters of galaxies, we see impressive and highly developed galaxies that look as if they are already several billion years old. How can these galaxies exist? What many people didn't know is that Hubble had already discovered a number of very old galaxies that didn't quite fit the picture back then. At that time, however, galaxies that existed 500 or 400 million years after the Big Bang were regarded as individual exotics and special cases. In addition, it was not entirely clear whether the light spots were actually complex galaxies. Hubble's images were nowhere near as informative as James Webb's images are now. Bright and luminous objects in the early universe could also have been clusters of the famous population 3 stars. These are said to have been the very first stars in the universe, which were much larger than the usual types of stars today and consisted mainly of light elements. These stellar giants had a luminosity that would make today's stars look pale, but they burned up after only a few 100,000 or million years. Now we know from Webb's analysis that there are millions or billions of stars within these blurry-looking patches of light. This does not fit with the old assumptions of a few giant stars clumping together to form protogalaxies. Many of the galaxies examined by Webb already show complex structures, such as spiral arms and bars, which also speaks against a young developmental stage of the galaxies. However, GZ9 P3 is a real mystery among the very old galaxies discovered so far. For other reasons, it is not only more massive than expected but also about 10 times more massive than other galaxies that the Webb telescope has seen in a similar epoch of the universe. The complex shape, with 2 bright spots revealing dense cores, suggests that GZ9 P3 probably formed when 2 early galaxies collided. In Webb's detailed images, a large number of young, bright stars were visible within GZ9 P3. This young, bright stellar population was probably formed by the galaxy merger and is less than a few million years old. Within the galaxy, however, Webb also found an old stellar population that is already over 100 million years old. The GLASS scientists used Webb's advanced spectrometer to uncover all this fascinating information about this extremely distant galaxy. It is fascinating what we can now discover today, thanks to our technologies. Being able to observe details of a galaxy more than 13 billion light-years away is a great stroke of luck for our cosmologists. With the help of Webb spectroscopy, we can even determine the elements that make up these stars. Since young and old stars have different compositions, the researchers were able to separate the two categories in this early galaxy. Older stars usually appear redder and are richer in heavy elements, which astronomers also refer to as metals. If old stars have largely burned up the hydrogen supply in their cores by fusing it all into helium, this helium is then burned, and even heavier elements are formed. Younger stars, on the other hand, are still dominated by hydrogen and some helium and are thus clearly separable from the older stellar populations. For Webb, GZ9 P3 is rich in silicon, carbon, and iron, the latter being the heaviest element that can be synthesized by stars. This means that when these stars died in supernova explosions, they would have enriched the early universe with metals. Much of this metal content would later have become the building blocks of the next generation of stars. Our galaxy, the Earth, and ultimately ourselves are also composed of elements that were hurled through space by massive supernovae. Adam Reese stated that we have misunderstood the universe. It's a fascinating fact that the best telescope in the world, the James Webb Space Telescope, confronts us with so many new facts and that we have to completely rethink cosmology. Adam Reese, the Nobel Prize winner and researcher at Johns Hopkins University in the USA, has been researching the so-called Hubble tension for a long time. He realized before Webb's launch that we probably had a glaring error in our previous understanding of the universe. Reese is one of the leading scientists when it comes to researching the Hubble constant, the rate at which the universe expands. Scientists have used this constant to determine distances, expansion speeds, and also the age of the universe. Reese and his team researched the discrepancy in the measured values for the expansion rate, which occurs when the measurements are fixed at different points. Measuring the universe and dynamics within the universe is not so easy because all objects are in constant motion, and we have no walls of space that we can use as measurement constants. Scientists base their measurements on objects and events that are considered to be the most constant, and these are usually phenomena that emit a lot of light. Light is considered to be the most reliable quantity in the universe. However, light is also in constant motion. Another source is the cosmic background radiation, which resembles an imprint of the earliest events in the universe. Measurements of expansion based on cosmic background radiation have shown an expansion rate of about 67 kilometers per second per megaparsec, while research based on data from Cepheid stars has shown a rate of about 73 kilometers per second per megaparsec. Adam Reese and his team were able to refine their work thanks to the Webb telescope and wanted to find out whether a potential measurement error of the Hubble Space Telescope could be the cause. But Webb showed the same deviations, which is worrying. Somewhere between these two observations, there must be a fundamental flaw in our understanding of the universe, said Reese in an interview with the Astronomical Journal in the USA. The use of the new space telescope has allowed us to look deeper into the universe through its sharp infrared view and to study cosmic distances even more precisely. Now that we know that Hubble and Webb confirm the significant deviations, we can be sure that there is an error. For Adam Reese and his team, this is a step forward. If measurement errors can be ruled out, we need to look into our other thought constructs and theories to see where the error is hidden that can explain all these strange observations and apparent impossibilities. Since Webb took up its post, the discoveries that are not compatible with our old theories have been piling up. Adam Reese, who was awarded the Nobel Prize in Physics in 2011 for discovering the accelerated expansion of the universe, sees these findings as an opportunity to advance science. If our previous measurements of the universe are not correct, the determination of age, the idea of expansion, and even the idea of a Big Bang could be wrong or at least not quite right. The universe may be much older than previously thought, and these discoveries even have implications for the history of the origin of matter. Unexpectedly massive and highly evolved galaxies clearly indicate that the universe 13 billion years ago and more was not what we previously thought. New perspectives on the universe. What do you spontaneously think of when a scientist like Reese claims that our picture of the universe is probably completely wrong? An infinite universe, the crazy dimensions of string theory, or the possibility that there are millions of universes according to quantum physics? Let's take a look at what potential new cosmological pictures could now be coming. Scientists are currently still vehemently refusing to open the door to theories such as the quantum universe on the basis of the new observations. Instead, they believe that the deviations in the Hubble constant could be due to misunderstandings or misinterpretations of dark energy. This mysterious force, which is understood to be the driving factor behind the accelerated expansion of the universe, is largely unknown in terms of its properties and behavior. It could be, for example, that dark energy is not evenly distributed throughout the universe or that its effect changes over time and space, which then leads to the different measured expansion rates. Another line of thought could concern the equally mysterious brother of dark energy, dark matter. Dark matter is another important component of our ancient cosmology, but here too the catch is that we have never been able to prove its existence and thus its true properties. Perhaps we overestimate its uniformity and underestimate the complexity of its distribution in the universe. Irregularities in the distribution of dark matter could influence the cosmic structures and the observed expansion rates in exactly the same way as we are currently experiencing. Recent discoveries by the James Webb Space Telescope are pushing the boundaries of our understanding of cosmic evolution and challenging the very foundations of astrophysics. For instance, the telescope's findings suggest that some of the earliest galaxies in the universe may have developed more quickly and complexly than previously thought. This poses significant questions about the rate and manner in which galaxies form and evolve. A key aspect of this new research involves the detection of massive galaxies in the early universe. Traditionally, it was believed that such large and developed galaxies could not have existed so soon after the Big Bang. However, the Webb telescope has identified several of these early massive galaxies, which seems to contradict established models of galaxy formation. The presence of these massive galaxies suggests that the processes responsible for their formation might be fundamentally different from what we have assumed. Moreover, the unusual characteristics of these galaxies are forcing scientists to reconsider the role of primordial conditions in shaping galaxy evolution. For example, the rapid emergence of complex structures in these early galaxies might indicate that the conditions of the early universe allowed for more rapid star formation and galaxy assembly than previously expected. This could mean that our models of how galaxies merge and grow need significant revision. Additionally, the discovery of diverse stellar populations within these ancient galaxies provides new insights into the processes that governed the early universe. The presence of both young and old stars in these galaxies hints at a more intricate timeline of stellar evolution and galactic mergers. Such findings suggest that the early universe might have had a more dynamic and diverse range of stellar and galactic activities than previously understood. The implications of these findings extend beyond just galaxy formation. They challenge our understanding of the cosmic timeline and the evolution of cosmic structures. For example, if galaxies were forming and evolving more rapidly than previously thought, it might also impact our models of cosmic reionization, the period when the universe transitioned from being opaque to transparent. Researchers are now exploring how these new observations could be reconciled with existing theories. Some are investigating whether modifications to the standard cosmological model might be needed, while others are considering alternative theories, such as those involving new types of dark matter or variations in dark energy. These theories are being scrutinized to determine whether they can account for the rapid galaxy formation and complex structures observed by Webb. As astronomers continue to analyze data from the Webb telescope, the focus will be on refining our understanding of the universe's early stages. This involves not only examining the properties of these newly discovered galaxies, but also integrating these findings into a broader cosmological framework. The ongoing research aims to provide a more accurate picture of the universe's formation and evolution, potentially leading to a revised cosmological model that better fits the observations. Ultimately, these discoveries highlight the importance of continual observation and theoretical development in astrophysics. As technology advances and new data become available, our understanding of the universe will continue to evolve, leading to deeper insights into its origins and structure. The challenge now is to incorporate these groundbreaking findings into our existing knowledge and to explore the new questions they raise about the cosmos.